All right, we should be on this page. Before we get too far into our notes, though, let's just remind ourselves what we did with that activity on Friday, where you guys were doing the Desmos with the curling and with the Tetris. And in those activities, you were kind of given like ways to move the shape, especially like on the curling one. How do you arrange transformations so that you got it in the target? And if I was asking as the question in class on Friday, it was, does the order matter? Did it matter if you did a reflection followed by a translation, or could I have done the translation and then followed the reflection instead in order to get the same location? And after we did those activities on Friday, we talked about it at the very end of class, and we noticed that the order does matter. You have to kind of follow a specific sequence of events in order to get the shape in a designated spot. You can't just do it however you feel and get it to be in the same ending location. It's kind of like order of operations a little bit. You know, when you're solving something with a lot of numbers and you had to kind of follow, you know, are there any parentheses? Are there any exponents? Then multiplication and division, addition and subtraction. It matters the order that we solve problems in because we all want to make sure we get the same answer. So when we do these transformations that are combined, it matters that the order we do them in. We want to make sure that we're performing them in the correct order so that we get to the same ending location. The way we're going to talk about those today is composite transformations. So composite is kind of like a word that means combination. We're taking two or more of these things and we're trying to put them together and perform them both on the same shape or the same line segment. And it's the term we use when a sequence of transformations takes place. For example, we could rotate an object and then we could do a translation of that image. So let's talk about how you're going to see this with notation today, because we're going to be given it symbolically and we need to know, well, which one do we do first and which one do we do second? So if they spoke it out, and that's kind of what they're reading or writing like right here, where it says example, this is if someone was like just verbally telling you what they wanted to have done. They're saying take triangle ABC, it's rotated 270 degrees about the origin, followed by a translation with that vector 9, -3. Let's just break this apart. It says it was rotated 270 degrees about the origin. I'm going to underline that because that's what happened first. So they did a rotation. They use the origin as their center of rotation. That's what it means when they say about origin. They're telling you what's the point that they use for the center. And then they did 270 degrees. Then it goes on to say followed by a translation with that vector 9, -3. So that's the second thing that we did to it. We started by doing the rotation. We followed it up with a translation. Now, if you look at the notation right underneath it, this would be how we would write it like in math terms. You'll notice that that triangle ABC is in the parentheses there. But look at what came first, like right in front of that. That rotation that they talked about around the origin of 270 degrees. And then the translation is written even before that with that vector 9, -3. So when you guys see your notation today, whatever is closest to the thing in parentheses is what you're going to perform first. So this is what I would do first, and this is what I would do second. Okay? So make sure, I know it's kind of backwards because we would almost think, well, wouldn't you just read it like left to right? But like I said, it's kind of like that order of operations. We have to know how to read the notation so we know what to do first. Whatever is attached or right in front of the shape that you're performing this on, that's going to be the piece inside those parentheses. Whatever is right in front of that is going to be what you do first, and then it's going to be followed by whatever was written at the very beginning. Okay, so when we look at these first examples down here, number 1, all they want you guys to do is read the notation here. So this one says rotation around the origin of 180 degrees, followed by a translation with the vector 3, 4. They want you to circle down below. Which one would you do first? So do that for part A and for part B. Go ahead and read those and circle. Which one would you do first? So for A, which one are we circling? The rotation or the translation? Good, translation, because it's first, like right next to the parentheses, so that one's going to go first. How about for B? What? Why? Yeah, because it's closer to the parentheses. Now they're both reflections that time, but we have to then look at like the subscripts to be able to differentiate down here. So that's why I'm circling the y equals x one, because that's right next to the term in parentheses. And then you would do the other reflection that they ask for. Okay, so now what we're going to do is kind of take that words example and be able to write it with the math notation. Now I'm going to want to see you write it like what they had up here. I'm going to want to see things written like this with all those symbols. Let's do a quick recap. Remember, little r means reflection, and right after the little r, like in the subscript area, is going to be the line that you reflect over. And we saw that up here where it said little r x-axis, little r y equals x. Those are reflection notations. Capital R means rotation. And in the subscript area there, you need two things. You need your center that you're rotating around, and you need the angle that you're rotating around. And then the capital T stands for translation, and then that's when we saw the vectors show up. So that's what we need to keep in mind when we're writing these out. So we're going to do this first one together. So part A says, given triangle ABC, and they already put that in the parentheses for me. The first thing they want me to do here is translate it by the vector -5, 3. Okay, so what letter do I use for translate? T, capital T, and I'm going to put it in the blank closest to that parentheses, because that's the one that goes first. So capital T, and then all I need in my subscript is my vector. What did they tell me my vector was here?
5, 3, or -5, 3.
Yep, -5, 3. Good. So that's just going to go right next to it. Make sure you're using the vector form, not parentheses. Okay, then it goes on and it says followed by a reflection over the x-axis. Okay, I use R for reflection, but is it a big R or a little r?
Little.
Good, little r. And then in my subscript, it's what I'm reflecting over. What are they saying I'm reflecting over?
Over x-axis.
X-axis. So I'm just going to write x-axis right there. Perfect. Okay, you guys try B. Okay, from what I could see up there, it looks like you guys at least understand the right order. I talked to a couple of you, but with that rotation, are we using a big R or a little r? Good, big R for rotation. And then what two pieces do I need in that subscript area? Greer? Good, O and then 73. I saw a lot of you have the 73. A couple of you missed the O. Make sure that you have that center point there as well, because we need to know what are we rotating around, and then how many degrees is it being rotated. So I need to see both of those things. And then in the first blank, what'd you guys write? Keegan?
Capital T and then the whatever things.
Vector.
Vector and then 11, 9.
Good. There you go. Okay. We good so far on reading the notation, guys? All right, for this next part, we're going to actually perform these. And some of them are going to require us to do rotations. So you might want to have patty paper for these. And I'm going to switch over to my doc cam and actually do these with you. Before we get too far into it, though, does anyone need patty paper? Okay. All right, so first thing that I want to do here is figure out what I need to do first. So if I look at my notation here, and if you guys also notice, both of these problems have a lot of the same pieces to them. We are starting out with the same triangle, ABC, on both graphs here. They both have this rotation around the origin of 90 degrees, and they both have this translation with that vector 3, -5. What's the only difference here?
Whichever closer to the parentheses.
Yeah, they're flipping the piece that's closer to the parentheses here. And they're asking right above here, which we should already know the answer to this question based on what we talked about on Friday. Does the order we perform these transformations in matter? It does matter. So when we do these two problems, even though we're using the same types of transformations, they should end up in two different areas. So our two pictures down here should not look the same because we kind of figured that out on Friday. So I'm going to start with number 1, and I want to do this rotation of 90 degrees first because that's closest. So I'm going to put my pad of paper down, and I'm going to trace this triangle ABC on here so you guys can kind of do this with me. And then we're going to do that rotation around the origin. So I'm putting that on my graph as well. Okay, and then I'm going to put my pencil on O. In which direction should I turn my paper to go 90 degrees?
Left.
Good, left, counterclockwise. So there's one turn, and then I should be able to just kind of lift up my paper and get those points in the right spot. So I have A, it looks like it's at -8, 2. Do you guys agree with that? And we're going to call that A prime. And I'm going to do the same thing with my B and my C. Those both look like they're at 7 on the y-axis. B's over at -6, and C is at -2. Again, I'm labeling that B prime, C prime. Make sure you guys are labeling your pictures. We talked about that last week when we went over your quiz. You want to make sure that you label A prime, B prime, C prime. I want to see those things. Okay, so there's my rotation. Now I'm going to do the second transformation, which is this translation. So all I need to know, I don't really need pad paper for this anymore. I need to know what directions to move it in. So what direction does the 3 force us to go? Right 3, and then the -5 makes us go down. So for all 3 points here, I'm going to go right 3. I'm going to start with the C prime. Right 1, 2, 3, down 1, 2, 3, 4, 5. How do you guys think I should label this point though, since I already used C prime? C double prime. So put C and then put 2 dashes next to it. Okay, make sure you label all those points, A double prime, C double prime, B double prime. Okay, but you can kind of see that's where my end result is. This would be considered like the final answer because that's where it should end because that was the second transformation that we had to do. But I do want to see both. I want to see the first transformation followed by the second one. Okay, now if we look at number 2, right next to it, which one are we going to do first?
Translation.
Good, the translation. Now, I didn't change my vector at all, so I'm going to go the same directions, right 3 and down 5. So I'm going to start there. Okay, now we need to do this rotation. Okay, so I'm going to retrace. This time I'm going to trace that shape I just had. A prime, B prime, and C prime. And we're still going around the origin. And we're still doing 90 degrees. So everything's the same as what we did. I'm going to put my pencil here. I'm going to turn it to the left one time. And my rotation should end up here in this area. Okay, and then you're going to go ahead and copy those points down too. Did everyone get their triangle to go up there?
Yeah.
Okay, so now I'm going to go ahead and copy those down. So I have A double prime being at -3, 5. B double prime I have -110. And C double prime I have 310. Okay, so down here at the bottom, they're asking, what do you notice about the location of the ABC double primes in the two examples? Are they the same or are they different? Different. The end results are in two different areas. This one ended here, and this one ended up here. So I'm going to say the end locations are different. So does the order matter?
Yeah.
Yes. Questions on how you perform those? Make sure you always do the one closest to the parentheses first, and then do whatever was before that. That's always your second one. Okay.